This one is a challenge. In Lab 6A14, you are to create a V shape of n stars, as shown in the diagram, reading the values of n from a data file. This video will show all 6 of the necessary steps to make this happen. Creating the solution for this could be considered a rite of passage for the beginning programmer, who, after producing a successful solution, can say with pride, "I solved the V-shape by myself." Therefore, if you want to be able to claim that feat, don't watch this video yet. It will show you the solution. If you want to stop to ponder your own attempt, now would be the time to pause this video. If you want to see the next steps for the solution, keep watching. Here we go. The first challenge is to set up the for loop to output both stars in each row in a simple column like this. We use a printf statement, so we can use the special indenting technique demonstrated in the previous videos for Labs 12 and 13. If you haven't yet watched those, stop and view those now. The second step is to indent the left diagonal, and we use the indenting technique learned in Lab 12. Nothing really new here. We insert the value x into the format string so that an increasing field width is used to push over the first star in the output, the second star right behind it. In the third step, we begin separating out the second star using the same indenting technique with the value x, but you can see it doesn't quite work. It creates a shallower diagonal with the second star leaning the same way as the first diagonal. No worries. In the next 3 steps, we will proceed to make the proper adjustments. In the fourth step, we introduce the value of n into the indenting expression, subtracting x from it. We also must add 1 to prevent the field width from descending to 0, which causes a runtime error with printf, which cannot have the value 0 as a field width. If we break this down, you can see how this works. In the first output, the value of n is 5, and when we subtract the value of x, we get 4, and then add 1 back to get 5, as the indenting field width for the first star of the right diagonal. When x becomes 2, the new field width is 3, plus 1, or 4. This continues until x is 5, which produces 0 when subtracted from n, plus 1, a field width of 1, which outputs the second star at the bottom of the V shape. The output produced here for the right diagonal is still not correct, a vertical line, but we're getting closer. Ready for step 5. In step 5, we need to increase the field width for the top row star, and so we simply double the value of n. This creates the same vertical row of stars for the right diagonal, pushed farther away. Still not correct, but only 1 step away from the final solution. In step 6, we double the value of x being subtracted from n, and this produces the final correct output. When the value of n is 5, the field width created is 5 times 2, or 10, minus 1 times 2, plus 1, a total of 9, which is the field width needed for the top row second star. When x becomes 2, the field width is 5 times 2 minus 2 times 2, plus 1, a field width of 7, perfect for the second row second star. This continues all the way down the V with field widths of 5, then 3, and then 1 for the second star of each row, creating the V shape. And there you have it, the solution for the V of n stars. If you did that yourself, it's time to celebrate. Get up and do a little dance. Great work!